So what we're going to do here today is actually build the financial model for Ovid Therapeutics. So what we're going to do is we're going to use Fintepla, which is a similar drug that recently got FDA approval. It's called fenfluramine hydrochloride. That's the kind of the molecule name. However, it is called Fintepla. It was approved in June, 25th of June, 2020, and it actually reached market in 2022. So this is really important because the time from actually gaining FDA approval was 614 days, so about a year and a half, or a little bit over a year and a half. And then we're actually going to have to include this in the model. Now, another thing that we have to also include is the time. I'm just going to put a note of this. So let me put a note of this, and we're going to take this from the company that currently actually runs Fintepla. So this is going to be kind of like our benchmarker drug. This is the drug that we're going to use to actually benchmark. So let me just put a note. Let me put insert. Is there like, there we go. There is actually. I do like these, however. Okay, let me go. First of all, I want to change the background of this thing. Let's go with fill, solid fill. Or let's go with this very light yellow, like a notepad, or like a sticky note. Okay, so what we're going to need is actually the time from approval, no, the time from finishing phase 3 clinical trials to what? To filing, and then receiving FDA approval. So we're going to have to know that timeline, and the reason is that this is actually going to have to go into our DCF model, which we're going to do in a bit. So first of all, I actually wanted to start with the disease model. So we're going to have to actually estimate the exact target or the total addressable market when it comes to Dravet syndrome and then Lennox-Gastaut syndrome. I hope I'm pronouncing it right. But starting with the birth rates, because we're going to use incidence and prevalence data, so these are kind of like the data that you're going to have on hand. So here I'm going to go with, let's go 2023, 2024, 2025, 2026, 2027, 2028, 2029. Of course, 2030, 2031, 2032, 2033, 2034, 2035, 2036, 2037. I don't know why I did this the long way, but I gotta. Let's go control. Let's go command E, I think. Yep. It's gonna like center all these. So this is actually going to be the projected years. I'm not going to worry too much about formatting. But the birth rate per 1,000 people. This is something you can actually get from, where did I get this actually? Macro trends. But this is, you could actually get from macro trends, and it's pretty much going to be the same thing. But this is the birth rate per 1,000 people in the US. Right? And let's just make it normal formatting. I'm going to keep this formatting actually very simple because I just get carried away sometimes. So this is going to be that, and then I'm going to have these model or target market. I don't know if that has any other names. This is kind of what we're going to be doing. Oopsie daisy. Okay. So, okay. The population in the US, and this is kind of its projected population as well. Copy. And I'm just going to paste values. Keep source formatting. Just paste values. That's all I care about at this point. Okay, this is awesome. What else do I need now? What else do I need? Okay, the number of births in the United States. And you can actually calculate this. So this is going to be equal to... So how do I calculate the number of births in the US? So this is going to be equal, because it's per 1,000. So it's going to be equal to the total population, and then you divide it by 1,000 per 1,000 people, right? And then you multiply it by the number of the birth rate. And voila, so you get 4 million. So these are the number of births each year in the US, projected all the way up to 2027. Is this correct? It is correcto. Okay, life expectancy. Now, honestly, I don't think this is really important. Like, if we do a sensitivity analysis, like, this being accurate is not very important. But I do want to use it because I might include it. I might include it when calculating the prevalence of diseases. So I'm just going to keep life expectancy here in the US. And then here you have the years. Okay, perfect. So now we're going to be targeting, so to give you kind of a quick overview, Ovid Therapeutics is developing soticlestat, or also called OV935, also called TAK935 as well. Now, this drug is going to be used to target, to treat Dravet syndrome and Lennox-Gastaut syndrome. Now, these are very rare diseases, or they're kind of these developmental, pretty much seizures start at a very young age. I'm not sure exactly, but they're very rare seizure disorders that start very young, and they affect basically and this is why this drug has orphan designation. It's orphan designated, meaning that's being developed for a very small fraction of the market. And of course, because of that, they're going to demand a very high price when they sell this drug. So these are orphan medications. Okay. So taking a look, right? Let's take a look at it. Life expectancy. Okay. So let's take a look at the stats and then see how we can, so these are kind of like all inputs up to this point. So let's look at kind of the prevalence. Let's start with, let's say, Dravet syndrome, right? And, oh yeah, of course, we're going to be looking at 3 main markets. It's going to be Europe, Japan, and the United States. And the reason is that the Takeda kind of has it covered in Japan. Europe is, after FDA approval, is just, you know, it's kind of, it just automatically extends there. The United States also probably the biggest market here, in terms of monetary, in terms of like money. So we have to kind of do a good job in estimating the target number of patients that this drug can actually reach. So just bear with me. This is going to be the first step, okay? So we're going to start with Dravet syndrome, right? Let's start with this disease right here. We're going to start with Dravet syndrome. And let's start with the United States. Oh, no. Let's start with, let's start with the United States. United States. States of America. United States of America, right? And then we're going to have 1, 2, 3, 4. No. Let's go with incidence and see things. And then, right, incidence and prevalence. Let's start with this. Boom, boom. And then boom, boom. Okay? So, shit, this is actually going to be very important. Okay, so let's start with the prevalence. let's start with the incidence in the United States. So LGS incidence in the US is estimated at between 0.1, so it's estimated between, I'm not going to put it here yet, it's going to be estimated between 0.1 to 0.28 per 100,000 people. Per 100,000 people, right? This is how the incidence, okay. This is the incidence of it. So we could either take the high end or the low end here. We could actually, it's actually very hard to actually calculate the prevalence of this disease. Now, I'm sorry, I made a mistake. This is not Dravet syndrome. Okay, that was actually LGS. Not bad. Okay, so Dravet syndrome. The incidence is 1 in 15,700 births. So it's going to be 1 in 15,000 and then 700 births. Live births. So that's kind of the incidence. So the incidence, of course, as we all know, is going to be the number of new cases of a certain disease each year. That's the incidence. And then the prevalence is actually the actual number of active cases or the actual number of people with this disease at a specific point in time. Okay, so looking at the prevalence data real quick, it's actually estimated that it is between 39,000, and I have to actually cite this, but 39,000, I keep going to LGS, man. Okay, I couldn't actually find a prevalence, right? But I did find this incidence data. Now, the mortality rate, right? Let's go with mortality, right? And then let's just go for the US. I'm just going to put here, let's go with, oopsie daisy. Let's go with prevalence, right? Okay. So incidence here, and then you have the mortality rate. Motherfather. Okay, so the mortality rate, now this is actually a lot of data on this stuff, but if you actually think of like the population of people with a specific disease, you can think of it like a cup of water. So the incidence is kind of the flow into that cup, and then you have the prevalence, which is the amount of water in that cup at a specific point in time. And the mortality rate is, of course, the leak. So how many patients you lose each year, because patients die. So let's take a look at the mortality rate here is 9.32 per 1,000 person years. Now, there's a lot of stuff here, honestly. I'm just going to add a note because I'm not even sure how I'm going to use this. So let me put a new note here, right? So this was actually it, the mortality rate. Motherfather, okay, 9.32 per 1,000 person years, 9.32 per 1,000 person years. And I think the total mortality is going to be what? 15.84 per 1,000 person years. I think the upper one is actually mortality rates that are due to, I think it was status epilepticus. Status. So that's kind of something to ponder about, but I'm not even sure I'm actually going to be able to use this. But let's say, okay, let me end this here.